Welcome to Edgecore Enterprise Switches training program. In this course, you will learn how to use various tools to manage and monitor your network switches such as CLI, SNMP, and Syslog. In addition, you will also learn how to synchronize time using NTP. By the end of this course, you will be able to use different tools to manage Edgecore Enterprise Ethernet switch, understand the concepts and functions of NTP, SNMP, and Syslog, configure and use NTP, SNMP, and Syslog on your switches, optimize and troubleshoot your network with SNMP and Syslog. I hope you are excited to learn more about these tools and how they can help you improve your network management skills. If you have any questions or feedback, please feel free to contact us anytime. Let's get started. In switch management, we provide users with multiple methods for accessing and managing Edgecore switches, including CLI, Telnet, SSH, and Web User Interface. Here's a brief overview of each method. The CLI program can be accessed by a direct connection to the RS-232 serial console port on the switch, or remotely by a Telnet or SSH connection over the network. With the Web UI, users can interact with the switch through a graphical interface that they can access from any web browser. SNMP is a protocol that enables system administrators to exchange information with different devices on a network. To connect a terminal to the console port, we need to complete the following steps. First, connect the console cable to a PC that is running terminal emulation software. Here, we use TerraTerm. Second, make sure the terminal emulation software is set as follows. 1. Select the appropriate serial port, for example, COM port, in our example is COM6. You can use Device Manager on your Windows system to find the correct port ID. 2. Set the baud rate to 115,200 bps. 3. Set the data format to 8 data bits, no parity, and 1 stop bit. 4. Set flow control to none. 5. Set the emulation mode to VT100. The CLI program provides 2 different command levels: normal access level and privileged access level. The normal access level can only access a limited subset of CLI commands. Edgecore Enterprise Switch supports up to 16 username and password pairs. We need to pass the authentication before we can access the switch. The Edgecore Enterprise switches built in a Telnet server that allow users to access CLI from remote host. The Telnet uses TCP protocol and listened on port 23 by default. After passing the authentication, users can access the CLI of the switch by using a Telnet client software, such as PuTTY or TerraTerm. Telnet is an outdated protocol that is seldom used nowadays because of its security risks. We recommend that you only use Telnet locally because Telnet exposes the data in a plaintext format. SSH is a network protocol that uses encryption to make the remote login and command line execution more secure over an unsecured network. SSH set up a secure connection for data transmission. If someone captures the packets, they cannot decrypt them without the keys. The Edgecore Enterprise switches have a built-in SSH server that let users access the CLI from a remote host. It supports both SSH version 1.5 and 2.0, but they are not enabled by default. We will show you how to enable SSH in the next slide. SSH is considered a more secure alternative to Telnet and is widely used for remote switch management. In Edgecore switches, SSH service is disabled by default. Before we can use the SSH server, we need to create RSA host keys. To do this, we can enter the command IPSSH crypto host key generate. Then, we can turn on the SSH server with the command IPSSH server. When the switch receives a connection request from the client, it uses RSA to exchange keys with the client. Then, it agrees on the encryption method with the client. After generating the host key and enabling the SSH server, we can use the show IPSSH command to check the settings. When SSH clients connect to our switch, We can use the show SSH to display the status of current SSH sessions. The show users command shows all active online login users, including console, telnet, SSH, and HTTP sessions. The information includes username, privilege, idle time, and IP address of all login users. With the web UI, users can interact with the switch through a graphical interface that they can access from any web browser. They just need to type the IP address of the switch in the browser's address bar, and they will see a user-friendly interface that allows them to configure and monitor the switch. This method is convenient and easy to use, as it does not require any special software or terminal emulation. This section will give you a quick overview of the NTP concept and show you some CLI examples of how to set up NTP and configure the time zone. Before introducing the NTP function, let's think about why it is important to synchronize time between network devices. First, troubleshooting and debugging. When something goes wrong on the network, you need to look at the log messages from different devices to find out the root cause and the sequence of events. If the clocks on the devices are not synchronized, it will be very difficult to correlate the log messages and identify the problem. Second, security and auditing. Some network devices use timestamps to authenticate and encrypt their communication. If the clocks are not synchronized, the communication may fail or be compromised. Also, some legal regulations require accurate timestamps on all logs for compliance and auditing purposes. Third, performance and quality. Some network applications and services depend on precise timing and synchronization to function properly. For example, VoIP, video streaming, online gaming, and financial transactions all require accurate time synchronization to ensure high quality and low latency. This page compares NTP and SNTP, two protocols that help devices synchronize their clocks over the network. NTP is more precise than SNTP, but SNTP is faster to synchronize. All series of Edgecore switches support both SNTP and NTP as clients. The decision to use SNTP or NTP depends on three factors: the device's position in the network, its memory capacity, and its accuracy requirement. This page shows the syntax of the SNTP setting command in CLI. Step 1. Set as the SNTP client. Step 2. Decide the IP address of the SNTP server or URL. Step 3. Verify the result via show SNTP. This page shows the syntax of the NTP setting command in CLI. Step 1. Set as the NTP client. Step 2. Decide the IP address of the NTP server or URL. Step 3. Verify the result via show NTP. The default time zone in our switch is UTC, Coordinated Universal Time. When using NTP to synchronize time, we need to calculate the time difference between the local time and UTC, and set the local time zone accordingly. This is to ensure the consistency of time among network systems in different regions. We can configure the time zone with the clock timezone command. The time zone is configured from global config mode and becomes part of the running config of the device. In the first example, we configure our time zone as type A, the name is just a word, and the device doesn't actually check if it's the name of a real time zone. Type A is 8 hours ahead of UTC, so I entered 8, and no need to enter the minutes offset, and then enter the after UTC option. After that, we use the show calendar to check the time zone has been configured as type A. We can simply enter +8 for 8 hours ahead of UTC. Just like this. Or just enter 8 instead of +8. That's the same thing. In the second example, we configure the name of the time zone as Vancouver. Vancouver is 8 hours behind UTC, so we entered 8, and no need to enter the minutes offset, and then enter the before UTC option. After that, we use the show calendar to check if the time zone has been configured as Vancouver. Alternatively, we can simply enter -8 for 8 hours behind UTC. Just like this. Please note that the minus sign cannot be omitted. SNMP is a protocol that enables system administrators to exchange information with different devices on a network. For example, they can get information about user login, logout, or port linkup, link-down events. In addition to CLI commands and web interface, Edgecore enterprise switches also rely on SNMP as an essential tool for effective network management. With SNMP, system administrators can monitor the status of devices and make configuration changes. In this section, we'll show you how to set up SNMP and use it to manage our Ethernet switches. Let's quickly go over some of the major advantages of SNMP. Centralized management. SNMP provides a centralized way to manage and monitor network devices, making it easier to keep track of the entire network from a single location. Standardized. SNMP is an industry-standard protocol that ensures compatibility between different vendors' network devices and management systems. This makes it easier to integrate diverse equipment into a cohesive network. Efficiency. SNMP is a lightweight protocol that uses minimal network bandwidth and resources. It doesn't impose a significant performance overhead on the devices it monitors. Real-time monitoring. SNMP enables real-time monitoring of network devices. You can receive immediate notifications when an issue arises, allowing for proactive troubleshooting and faster problem resolution. Scalability. SNMP is scalable, allowing you to add or remove devices from the network without significant reconfiguration. This is particularly important in large and complex networks. Extensibility. SNMP is extensible, allowing for the creation of custom management information bases, MIBs, to monitor specific devices or collect custom data. Before we start configuring SNMP, let's look at the architecture of SNMP. SNMP has 3 components: SNMP Manager, SNMP Agent, and MIBs. The left side is SNMP Manager, and the right-hand side is the SNMP Agent. The SNMP Manager sends requests to get or set MIBs objects values. The SNMP Agent replies with a response or sends traps when any events trigger the traps. The SNMP Agent and MIBs are already installed on our Ethernet switches. The MIBs file is a text file that lists the data objects used by an SNMP device. It is organized in a hierarchical structure with object identifiers, abbreviated as OID. It helps the SNMP Manager to translate and interpret the messages from the device, and request or change data as well, such as the device's status, configuration, or performance. To use enterprise proprietary MIBs, you need to load them into the SNMP management software. Then, we can use SNMP commands to query or configure the device using the OIDs defined in the enterprise proprietary MIBs. We use ECS4120 as an example. You can see the node of Edgecore networks beneath the enterprises. SNMP has different versions, and the most common ones are SNMP v2c and SNMP v3. The main difference between them is the level of security they provide. SNMP v2c uses a simple password, called a community string, to authenticate the devices. This means that anyone who knows the password can access or modify the device information. SNMP v3 uses more advanced methods, such as encryption and authentication, to protect the communication between the devices. This means that only authorized users can access or modify the device information, and the information cannot be intercepted or altered by others. SNMP v2c is easier to set up and use, but it is not very secure. SNMP v3 is more secure and flexible, but it is also more complex and requires more configuration. Depending on your network needs and environment, you may choose one or the other version of SNMP. This training course is at the basic level, so we will use SNMP v2c as our example. By default, SNMP is enabled with 2 default community strings, public for read-only access, and private for read-write access. To create our own community string, we can use the command SNMP server community. To enable SNMP traps, we need to use the command SNMP server enable traps. To set up the trap receiver, we need to use the command SNMP server host and specify up to 5 IP addresses as trap destinations. The show SNMP command shows us that the SNMP agent, the SNMP logging trap, and the community string ECS4150 are all active. The trap receiving host has an IP address of 192.168.20.245. Syslog is a protocol that records messages from various network devices. In this section, we will explain what Syslog is and how it works. We will also describe the format of Syslog messages, which have a standard structure that you need to know to read and interpret them. Moreover, we will introduce the different types of Syslog facilities and severity levels, which classify the messages by their source and importance. Lastly, we will show you some basic examples of CLI commands for Syslog. Syslog is an industry standard protocol for message logging. Developed in the 1980s, Syslog is widely used across different platforms and systems, making it a cornerstone of system and network administration. On network devices, Syslog can be used to log events such as interface link up or link down, changes of spanning trees topology, user login or login out, etc. The messages can be displayed in CLI, saved in the device's RAM and flash memory, or sent to an external Syslog server. Syslog and SNMP traps are both used for monitoring and troubleshooting devices. Syslog messages follow the standard defined by RFC 5424. They have a common structure that consists of 3 main parts: facility, severity, and message text. The facility indicates the source of the message, the severity indicates the level of importance of the message, and the message text contains the actual content of the message. Here is an Edgecore Ethernet switch Syslog message. The facility is used by the Syslog server to sort messages or to store messages in the corresponding database. The timestamp indicates the time of the message that was generated. Description is the detailed information about the event being reported, about what actually happened. The severity levels are from 0 to 7. We'll use a table to introduce severity levels in the next slide. The host indicates the device's IP address. Syslog has 8 severity levels ranging from 0 to 7. The most urgent is 0, and the least urgent is 7 for debugging messages. When we set the severity level to 6, the logs will include not only level 6 messages, but also messages from levels 5, 4, 3, 2, 1, and 0. Syslog facilities are an essential part of the Syslog protocol, providing a structured way to categorize log messages based on their sources or origins. Syslog facilities 0 to 15 are used to indicate the source of the Syslog messages from different system processes or daemons, such as kernel, mail, cron, etc. Syslog facilities 16 to 23 are used to indicate the source of the Syslog messages from different network devices. They are also known as local use facilities because they are not assigned to any specific process or daemon. They can be used by network administrators to customize the Syslog messages according to their needs. A Syslog server software can be found by using Google as a search tool. There is a wide range of Syslog servers to choose from, with different features and prices. Some are free of charge and some are not. This example shows a Syslog server system for your reference. You can see the date, time, Syslog client IP, facility type, severity level, and message information for each Syslog message. Now, we'll introduce some Syslog-related CLI commands. The logging process manages the Syslog messages that are stored in the switch memory or sent to remote Syslog servers. You can use these commands to turn on a logging process that records and sends debug or error messages. In our example here, we turn on the Syslog by the logging on command, and then use the show logging level to check the Syslog logging has been enabled. For user login and user logout, you can use the logging level command to define the message severity level. In our example here, we configure the user login message to severity level 4, warnings, and the user logout message to severity level 6, informational. Then use the show logging level command to check the user login and user logout severity level. Syslog messages will be stored in flash and RAM. This command decides the levels of messages to be stored in the flash and RAM. The no form returns the logging of syslog messages to the default level. The message level specified for flash memory must be a higher priority. For example, numerically lower than that specified for RAM, since the limitation of flash memory size. After the system is rebooted, the logs stored in RAM are erased, but the logs stored in flash remain. With the logging trap level command, you can control which log messages are sent to the remote syslog server based on their levels. The command takes a level as an argument and sends all messages with levels up to that level to the remote server. For example, if you enter level 7, you will send messages from levels 0 through 7 to the remote server. The facility represents the process that generated the message. Because Syslog was adopted early by the Unix system, these facility codes are mostly Unix-based. The facility types 16 to 23 are for local use. These are undefined custom values that are generally used for network devices. The logging facility command specifies the facility type tag sent in syslog messages. This type has no effect on the kind of messages reported by the switch. You can use the logging host command to specify a syslog server host IP address that will get logging messages. The maximum number of host IP addresses you can have in the list is 5, so you can repeat this command until you reach that limit. After adding syslog server IP addresses, we can use the show logging trap command to check our syslog server list. To see the log message in local memory, we can type the show log command. To delete the logs in local memory, we can use the clear log command to remove messages from the log buffer. The first example is to show logs stored in flash memory, and then delete them. The second one is to show logs stored in temporary RAM, and then delete them. Please note that only the super user has permission to use this clear log command. Guest user is not allowed to clear syslog. A great way to practice what you have learned in this unit is to apply the skills to your own switch. You could experiment with CLI commands using the local console, Telnet, or SSH, and manage your switch using the web interface or SNMP. You could also set up your NTP server and syslog server. This practice will enhance your familiarity and proficiency with these skills, and prepare you for future problems more confidently. Thank you for joining us, and we are looking forward to seeing you at the next unit. If you have any questions, please feel free to contact us at any time.